Okay, now let us go to the next problem. Anyway, in the previous problem, what I said was, given the true shape, we are able to determine the inclination of the lamina to a corresponding plane. And I did a rectangular plate. Say similar rectangular plate, I can also give, let us say, an isosceles triangle. An isosceles triangular plate can be seen as a equilateral triangle. Okay, for example, if I say an isosceles triangle is seen as an equilateral triangle in the top view, if I give, then what do you do then? Now we can see that isosceles triangle seen as a equilateral triangle in the top view means that particular isosceles triangle has to be inclined to HP. So since it is inclined to HP, I will consider surface with respect to HP, so that I will start from top view. Or I can also give, let us say, I will give one rhombus. Okay, a rhombus can also be seen as a square. Is it okay? So that we can have 4 different types of problems, especially when the true shape of the particular lamina will be seen in either in top or front view. So as we did first, I did a rectangular plate. Similarly, we can have a problem wherein an isosceles triangle can be seen as an equilateral triangle, or I can say a rhombus can be seen as a square. But I am just going to solve one more problem wherein a circular lamina. I think till now we have not done any problem based on a circular lamina. Let us do this problem. Okay, now a circular lamina can be seen as what? Let us say we have a circular lamina of some 50 mm. Okay, so that circular lamina of 50 mm, if it is inclined to a particular plane, it will be seen as what? So it will be seen as an ellipse. Ellipse of what dimensions? Because anyway, if I say ellipse has got major axis and minor axis. Okay, tell me what about the major axis? Major axis has to be equal to the diameter of that particular circular lamina, whereas the minor axis should correspond to the surface inclination to a particular plane. Okay, let us do this problem. Okay, a circular lamina of diameter 60 mm is resting on VP on a point of the periphery such that its surface appears as an ellipse in the front view of major axis of length 60 mm and minor axis of 45 mm. Draw the projections when the diameter of the lamina corresponding to minor axis is inclined at 30 degrees to HP. So as you can see, we can see only one inclination. Which inclination given? I given 30 to HP. So this inclination corresponds to what? This corresponds to a particular diameter. Since that we say that I cannot satisfy this at the first instant. So always remember, wherever I say side inclination for other laminas, if it is the diameter inclination in the circular lamina, that has to be satisfied only at the later stages. Okay, now what about the surface inclination? Now as you can see this, the circular lamina is seen as a ellipse where? In the front view. Now since it is seen as ellipse in the front view, this particular lamina, a square lamina, has to incline to what plane? It has to incline to VP. Okay. So I can just hold it like this. So anyway, if I hold it like this is the true shape of the circular lamina. Okay. So once I rotate in this way, then what will happen? Now this particular diameter will be foresharpened. See, anyway you can see this diameter will not see. Anyway, if you just consider the circular lamina, it has got a horizontal diameter and a vertical diameter. Now, if I rotate in this way, your vertical diameter will not change. That means it remains the original diameter, that is your 60 mm in this particular problem. But whereas your horizontal diameter is getting decreased. So once it gets decreased, that is an apparent length. So once it becomes decreased, we know that this diameter is decreasing means you are going to see that particular circular lamina as an ellipse. But in this particular case, it has to be rotated such that it should be seen as a 45 mm minor axis, whereas the major axis is 60 mm, which is nothing but the diameter of the circular lamina itself. Okay, that is your second stage. What about the third stage? Third stage I have given this minor axis is inclined at a particular angle to HP. Since I have given this minor axis, but the angle what I have given is what? I have just given this, the diameter of the lamina corresponds to minor axis is 30 degrees to HP. That means what? The minor axis itself is inclined 30 degrees to HP. So what do you mean minor axis is inclined? Because anyway your minor axis is your apparent length. Since the minor axis itself is apparent length, this angle has to be apparent angle. Since I given the apparent angle directly, you have to simply redraw the figure. So no need to determine the apparent angle. Remember this. So always we need to see whether it is required for us to determine the apparent angle or not. Is it okay? Let us do this. See, same problem. I would have given that it is resting on HP. I can give it. Let us say if I give resting on HP, then what will happen to this problem? I would have given this resting on HP, then I would have said that the surface appears as an ellipse where? I would have said top view. That is, it is seen as an ellipse in the top view of this particular dimensions. Then I would have said draw the projections when the diameter of the lamina corresponding to minor axis inclined at 30 degrees to BP. So if I give in this particular way, I would have started from top view. Now, according to the problem what I have given, I need to start from front view. Because remember, whenever say a point is resting on VP means I need to start from front view. Is it okay? Anyway, what about the orientation for this? See, anyway, for the previous cases and all, I used to bother about the orientation. But what about circular lamina? Circular lamina, what all I need to decide is whether it will start from top view or front view. Because orientation is same now, because only a circle. So let me draw that. I just written the square, a circle. Let us say these are the diametrical lines. But remember, you know that whenever a circular lamina is inclined to a particular plane, it will be seen as an ellipse. See, anyway, circle, I can just use the compass, I can get this. But if I want to get an ellipse, I need to get the location of the intermediate points also. That is, if I choose more number of points, I am going to get a smoother curve. But anyway, as an explanation, I will just consider only divided this particular circular lamina into 8 parts. That is 8 radial lines. Okay, let me consider divided by 8 parts. That is, I am just taking these radial lines at what angles? I would have taken these radial lines at an angle of 45 degrees. Let us say if I have taken this in 12 parts, then each distance between the two intermediate radial lines has to be 30 degrees. Okay. But anyway, let us say I am just considering only 8 parts. Okay. Again, I need to name this. So naming is important. Let us always start from the leftmost visible point in the clockwise direction, since we are starting from front view. Okay. So let us say A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash. This is the front view. I need to do the correct top view. So where do you draw the top view? It is given that resting on a point on the pedestal, its surface appears an ellipse. Anyway, where it is resting? On VP. Since resting on VP, I will consider as usual that entire lamina to be on XY line itself. Okay. So draw the projectors. Remember, since I have taken at 45 degrees, these two radial lines has to come on the same projectors. That is the advantage of dividing it into in a particular fashion. So draw these projectors. This is the lamina. So now A, B, C, D, E, F, G, H. See, without seeing this, I am able to do it. The reason is I have named them in a particular sequence. Because I can also start from anywhere I can start. But if you start anywhere, I need to see and then only I need to write it. But since I am doing it in a particular fashion, remember, naming is very important. So once you do naming properly, you will not go wrong later. Because always around mechanical procedure now. Because whenever you do mechanical procedure, always you will tend to do some mistakes. Okay. So if you do it in a systematic way, you will never do any mistakes. Okay. Okay, now what is the next step? So now we know that this particular lamina has to be seen as an ellipse. Ellipse of what dimensions? Ellipse of major axis 60 and minor axis 45. Since the minor axis means this particular AE. See, anyway, as you can see in this particular figure, this is my major axis. That is G and C, or CG is your major axis. What about your AE is the minor axis, the horizontal diameter. So horizontal diameter is going to compress. That will say that I am going to get the minor axis which will be for AE only. That is AE has to become smaller. So when that AE, because anyway now AE is already exponent. That is the reason I can see two circle in the front view. Now this AE to be rotated such that this particular AE to be seen as a minor axis of then 45 mm. That is, as usual, as I told you in the previous case also, first I need to get the corresponding front view, then I will get the inclination later. Okay, now let us get this. So what I do then? I will simply draw this major projectors. Okay, let us say anyway, let us say this is my corresponding to C dash and G dash. Now anyway I know that I want a minor axis. So if I say minor axis should be 45 here. But anyway, even ellipse is also symmetrical figure. What am I symmetrical? It is symmetrical about x axis as well as y axis. So what I do there? So since I given this as 45, I can take 22.5 on either side. Okay, so take 22.5 either side and get that points. Okay, so that this will be A dash and this will be A dash. Okay, now as you can see, I cannot, anyway I am interested in getting these points also now. I need to get these points also. How do you get these points? See, directly I cannot get. Then how do you get the intermediate points? To get the intermediate points, first I should show the inclination in the top view. But anyway, see, these are the critical points I had done directly. Because anyway I know that A, where do you get A? Because anyway given that it is resting on one of the point of the periphery on VP. So which is that point I am considering A only now. So A will be the next one only. So this will be A. What about E? Where do you get E? E will be the extreme point for this particular lamina. Then what do you do? And also we know that E dash should be on the same projector. A dash A, same projector. Then what you do then? I will just draw this projector. Then I will take this length AE. Then I am going to cut it. Is it clear? So this will be the point. So let us say now this is the lamina. So this is A and E. Okay, what about your C and G? Same thing. See, A dash A, same projector. E dash E, same projector. CG here. How do you get CG here? And then draw the projector. So this should be C and G. Now I need to mark the other points also. Anyway, now I already have drawn this so that this inclination is far which I am supposed to determine. Now anyway we have this reference figure. So take this distance and put it on either side because I have said symmetrical now. So I am going to get the points. That is, this is A, B, C, D, E, F, G, H. So I got all the points now. Now I need to get the corresponding points in the front view. How to get the front view? Anyway, draw the projectors. I know that BD should be on this projector. Where is B here? It is here. So draw the projector. And remember, it is a symmetrical figure now. I can take the same distance this side also I can take. Not only that, this distance also I can take directly because anyway I know that. I can just draw here also I can draw. Even if you draw in this way also, you should get there only. Okay. So this is A. This should be B, C, D, E, then F dash, F. Then already we have the H projector and H projector. This is H. Is it clear? Now as I told you, if I don't take more number of points in between AC, I don't know how the curve should be. See, I need to get a smooth curve. And also remember, when I want to draw this curve, you remember everywhere it is a critical point. That is, everywhere the curve will change, keep on changing the direction. That will say that I can consider each and every point is a critical point. That is the reason generally we recommend that we want students to take minimum 12 points. You should not take more also. If you take more also, it becomes so cumbersome. But better you take 12 parts so that between AC I will get 2 more points. So getting 2 more points to get that particular curve, it will be nice. So that you are going to get a smooth curve. Okay. So anyway, let me get this. Is it okay? Now we can see the front yoke, which is a circular lamina, is seen as a ellipse of what dimensions? Of 60 and 45. Okay. Now anyway, here it is CG. CG is what? It is a minor axis. So now it is given that in the problem. Anyway, this is second stage. What is the third stage? Now we need to satisfy this inclination. To satisfy this, it is given that draw the projections when the diameter of the lamina corresponding to minor axis. So what is meant by this? This particular point. Diameter. So what do we mean diameter? What do we mean diameter? That is your true diameter. So true diameter is given, but what is the angle then? So angle given is also true angle. Remember, for example, if I simply, instead of giving diameter, if I simply say that draw the projections when the lamina corresponding to minor axis is inclined. If I would have given directly minor axis, then we say that I would have given the apparent angle directly. But here it is given that the diameter of the lamina corresponding to minor axis, which is the diameter, this is the diameter. That means say that I have given the true angle. Since I have given the true angle, I need to determine the apparent angle with reference to HP. That is nothing but alpha. How do you do that? I would say that I cannot simply redraw the figure. If I simply redraw the figure, the minor axis itself is inclined at 30 degrees. But I have given the diameter corresponding to the minor axis inclined means I have given the true angle. I need to determine the apparent angle now. How to find the apparent angle? Same procedure as we have explained in the previous sessions also. Anyway, I know the true angle is 30 degrees, diameter is 60. So get that. So either like this or like that. So it will be any fashion. Let me say I will do it this way. This is a 30 degree line. So upon this 30 degree line I should take this true diameter. I will take this true diameter. So this is nothing but TL. Anyway, this is a locus point. This is the locus point or locus line rather. Now I know this is the apparent length. So with this as center, draw an arc. So maybe I will get something like a get. Okay, that corresponds to this minor axis. That is 45. So maybe something like a get. So now this is the minor axis. So now we can see if I extend this line. So this angle is how much? Theta. What about this? This angle has to be greater than that angle. So what is that angle I said? We said this alpha. Remember, in the top view we get phi and beta, whereas in the front view we get theta, true angle, alpha, apparent angle. Anyway, now I know this. Now upon this I need to get this ellipse. Then I can get the corresponding new top. Let us do this. Okay, anyway, I will find the center point. Then I will find this point and this point. Okay, so let me take this distance. Then take these distances. See, as you can see, there are all mechanical procedures, so I need not to explain too much. Is it okay? They are all common sense, so you can just get the points. But only thing is, if you do it in a particular fashion, you will get this particular redrawn figure at a faster time. But if you get confused, see, always remember, this figure is like this. That is, here all the lines are vertical. Here the line should be like this. So that means since I have taken this 30, these lines should be at what angles? at 60. So I am just going to get 60 degrees. Like then I am going to just get the transfer the distances. And remember, it should be a symmetrical figure about x-axis as well as y-axis. That we have to maintain. Okay, so let me get this. I just got this redrawn figure, and again transfer points. That is also very important. That is A dash, B dash, C dash, D dash, E dash, F dash, G dash, and H dash. Now I need to get the corresponding new top view. How to get the new top view? Same thing. Draw the horizontal projectors from the previous top view and draw the vertical projectors from the new front view. Okay, so let me do that. So draw these projectors, and as you know that projectors should be as light as possible. That you have to keep in your mind. You should not draw these lines. I written for A first. Let us say this is A, then I will draw it for B. So B is your then C, D, then F, G, H. Is it okay? Now let us get the points from. So as usual, A to B, B to C, C to D, D back to E. So as you can see, since I am doing by a rough sketch, you are not going to get properly. But anyway, once you do in your drawing sheet or using software, maybe later, you will get correct. Is it okay? Now as you can see, anyway as you can see, you will not get like this what I have got here. Because it is not exactly symmetrical. That is, you should have symmetrical this side, even this side and this side. Is it okay? But anyway, you see that finally, this particular circular lamina seen as an ellipse in the front view, and the side which is resting, I mean the corner, or I can say the point on the periphery which is resting on VP is inclined at, I mean the major axis, I mean diameter corresponds to that is inclined at 30 degrees to HP. Is it clear? Thank you. So as you can see, if you take more number of points, you will get a smoother curve. So you should be careful. Okay, thank you. But anyway, you have to understand the concept. Okay, so don't really see yourself why you are going to get like this. Anyway, I am not using any instruments now. That is the reason while getting these projectors, I am not going to get properly. Is it okay? Thank you.